Torre Devices was founded by my father in 1955. The essential product line was that of devices for the absorption of energy. We specialized in the use of fluid-type energy absorbers and dampers. In the military business, we branched off supplying our types of products to all arms of the United States government. Today, our market areas consist of aerospace, construction, and heavy industry. In the aerospace business, our main contracts are with the United States Navy, where we provide energy absorbers and dampers used on ships. Torre Devices has been working with NASA in the space exploration business since the earliest days of the Apollo program. Our tasks usually involve removing the umbilical and fuel lines from a space vehicle just prior to the instant of launch. In heavy industry, workplace safety is greatly enhanced by the use of our crane energy absorbers. In the construction trades, we provide seismic and wind damping systems for buildings and bridges of all types. The Torre Mayor project was the first new construction of a tall building that was using our seismic damping devices as the primary means of earthquake protection.
We were asked to take on the role as design architect for the Torre Mayor project in Mexico City. Our concept for the design evolved through discussions with our client, Reichmann International.
My name is Rick Ricker. I'm Director General of Reichmann International for the Torre Mayor project here in Mexico City. Reichmann, by its trademark at First Canadian Place in Ontario, the World Financial Center in New York, and Canary Wharf in London, has been a developer of world-class facilities.
A building of this magnitude is one that is a particular challenge, more of a challenge in Mexico City or in any high seismic zone.
We are in the command center of the National Earthquake Service of Mexico. These instruments are remote recorders. This small earthquake occurred 2 minutes ago in the chimney of Popocatépetl volcano. There is also a larger earthquake right here 3 hours ago that occurred in Acapulco, and those are the ones that we have to fear in the case of Mexico City. This is Popocatépetl volcano right here. These are the major volcanoes. The earthquake waves generally arrive from the south. They start exciting the mud left here by the lake, travel inside the mud, and they are reflected and bounce back and forth inside the valley.
We knew that the building is going to be in Mexico City, which is the worst possible seismic site. What we told the client is that we like to take this building and design them for the 21st century. So we went back to drawing board. We looked at it, that what do we have to do in order to contain the seismic excitations? And the answer was to utilize supplemental damping system.
The concept of damping is quite simple. All the damper does is take mechanical energy and convert that mechanical energy into heat. This is a transparent damper. It consists of a cylinder full of fluid, a piston rod, and what's called a piston head that has tiny orifices cut in it. As we pull the damper or push the damper, the fluid inside is forced around the piston head at high velocities. Dampers absorb energy. If I push the damper in, it does not bounce back and give me energy back. Because the damper is absorbing the energy, it is harmlessly dissipated to the environment as a small amount of heat after the earthquake has passed. If that energy had not been removed by the damper, that same energy would now be damaging the building structure. Simple, yet effective.
Taylor dampers have a linear behavior, so you can actually compute what the effect is going to be. You can design the building in such a way as that the building will perform exactly as you want it to perform.
In any steel building, you're going to get about 2% of damping. And this is what 2% of damping in a steel structure looks like. When I stop, you can see how it resonates. By adding a single damper, you're adding about 10% more damping into the structure. I moved at the same amount of speed, stop, building slows right down. Also, as you can see, the building isn't moving as far side to side, so you're reducing the deflection in the building. By adding the second damper, you're putting about 22% of damping into the structure. I can move this the same amount of speed, the model hardly moves, and as you can see, when I stop, it stops dead. There's no residual force in the damper. So when you take the building and you deflect it to its elastic point and you release, it stops right in the center without putting more force on the building.
Earthquakes are something that the population lives with on a regular basis. Therefore, it was incumbent upon us to be ready to answer any and all questions related to earthquakes when this building was designed.
After the dampers were made, we wanted to test them, simulating the effect of a strong earthquake. So one day we went up to Buffalo to Taylor Devices. We tested them on an impact, on shock type loadings. We were happy that the load velocity behavior of both dampers is pretty much what we were designing for.
When I first was approached with this project, I looked at it and I felt like I was in love with it. The building is tall, slender, and knowing the seismic conditions of Mexico City, I thought it was going to be very difficult to make it true. So we turned to the idea of implementing in the building additional damping. So we talked to the people of Cantor Seismic Group and Taylor Devices.
Taylor Devices takes great pride when we find ourselves specified on a project by the engineer as the sole best source of providing the required protection.
What impressed us about Taylor Devices is that their records that they had, the history of utilizations of these type of dampers in severe environments and their successful performance.
When we first heard the concept of the shock absorbers through Ahmad Rahimian and the Cantor Seismic people, I personally got quite excited about it.
And we liked the idea so much of the damper itself that we wanted to make sure it was seen from the outside, part of the image of the building.
The addition of our damping technology to the bag of tricks, if you will, of the engineer enables the architect to do things technically that never would have been permitted by the reviewing engineers as little as 20 years ago.
What it does, it reduces some of the constraints to design a building in a severe seismic zones like in Mexico City.
We felt to express the structural features could add to the perception of the building as a very safe building.
We want to show them off as they are because they're a beautiful piece of engineering. You can see them through the glass, and this is the effect.
We have dampers on all four of the outside walls as well as all of the four cross-bracing areas of the core.
We have placed them in such a way that we sort of mimic the human body. What it is that it's functioning the same way that as the muscles of our body functions and is holding the skeleton together. They follow a diamond-shaped pattern at certain intervals in the building. By placing them between two stiff structural elements, not only we would capture the horizontal motion of the building, we would also tap into the vertical motions of the building as a result of the earthquake. This is a very good solution.
I am George Rudd. I am the construction director of the Torre Mayor project in Mexico City. Another advantage of the utilization of the damper is that it will eliminate the bracing, which will minimize the view to the outside.
If we didn't have dampers, I imagine a lot of those beams would be bigger, a lot of the bracing would be larger and as well as more extensive.
There is no doubt in my mind that having the damper is quite of a improvement in any building, especially a high-riser in Mexico City.
This is the building that we're committed to build. It's a beautiful piece of art, but that's an abstraction. We need to make it reality. A reality for the owners and a reality for the occupants.
The latest codes issued in the U.S. by FEMA, the Federal Emergency Management Agency, now recognize the fact that dampers are a preferred solution to structures that must maintain life safety with the ability of the occupants to work through a major seismic event. We would like to see all major nations in the world adapt the lead that's been taken by FEMA.
Here at the Institute of Engineering, we coordinate a technical group that is in charge of updating the building regulation regarding structural safety in Mexico City. This technique of supplemental damping is particularly suitable for Mexico City condition.
We began interactive research with all of the major university centers related to seismic events many years ago. We've been a strategic partner with the U.S. Earthquake Center at the SUNY Buffalo campus since the early 1990s. The influx of money to the center has recently taken a dramatic upswing, and they are going to be doubling the capabilities of their seismic testing lab. We're very happy when a building owner comes forth and takes out his advertisements for his new building and broadly notes that his building has been improved with dampers for the purpose of making the comfort level and the safety level much more improved than it would be in a competing structure.
I'm absolutely comfortable because all of my consultants and the experts are comfortable, but I'm here to say that probably the ultimate test and testimony comes from my customers. Before they signed, they had their own independent third-party investigation. That report, in a nutshell, said that this design that incorporated the tailored devices met or exceeded even the California requirements. I take great comfort in representing that, and I have their permission to say so.
To all of Latin America, it will signify perhaps the rebirth of the modern-day trade between their countries and the United States and Canada.
This market has always been more focused on efficiency and productivity as opposed to aesthetics. However, since September 11th, certainly fire protection, structural integrity, and safety now are in the forefront of all of our tenants' minds.
Since 9/11, we've been stressing the fact that the origins of this technology were indeed related to the control of blast effects to protect large military structures against explosions.
Some characteristics could be given to buildings in order to avoid a very sudden and total collapse, at least to give the building enough time to withstand this extreme condition in order that the occupants could evacuate it.
Taylor Devices has been the leader in innovative solutions to shock and vibration problems for more than 40 years. Our products are the industry standard in all of the markets we serve, and not only do we have the reputation, we have products that have actually made it through the events they were designed to protect against, and the structures and the people have survived.